Okay, so the next set of lessons for matrices is on determinants and inverses. Okay, and this combines some scalar multiplication, not regular multiplication, but scalar. And then our next lesson will get into solving using those inverses, which will use some of the multiplication that you've already learned. Okay, so determinants are actually pretty easy. Yes, it's also known as Cramer's rule, but you're not going to actually be solving using Cramer's rule, so you're just going to be solving using inverses. But it is called Cramer's rule, and it has to be specifically a square matrix. And the good news is that you will be required to do 2 by 2 matrices by hand, but anything bigger than that you will be putting into the graphing calculator. And we're also going to have a lesson on how to do this in the graphing calculator. So determinants, you multiply the diagonals and then you subtract. So this is just a general form of the matrix, of a 2 by 2 matrix with 4 pieces, 2 rows, 2 columns. So you multiply the first diagonal, you multiply the other diagonal, and then you subtract the 2 answers. Okay. Now there's 2 different ways that you're going to be asked to find a determinant. Okay. Sometimes they're just going to say, what is the determinant of this matrix? Right? And you just look for that word, and this is what you'll do. Oh, that's a terrible line. Let's try that again. Okay, and that's what you'll do is you'll subtract the diagonals. Another way that you'll be told that you're looking for a matrix or a determinant of a matrix is you'll be told to solve. And instead of having this normal matrix looking little bars here with the little, indents, it'll look like absolute value bars instead. So it'll look like this, okay? And all you'll be told on this case is just solve. And I've seen these frequently on ACT and SAT practice books. And the thing is, you not only have to remember what it is, but you also have to remember how to do it. So in this case, solving these 2 matrices, we're going to do 3 times 4, so that's 12, minus, let me get a different color, 2 times 5, which is 10, and your answer is 2. The determinant of this matrix is 2. Determinant is a lot like doing the discriminant back when you were doing polynomials and quadratics and all that stuff. And the discriminant was like b squared minus 4ac, right? It was part of your quadratic formula. And it basically told you if you had real answers or imaginary. Well, a determinant for a matrix tells you whether or not you can have an inverse. Okay, so that's why it's kind of the first important piece. So we find 3 times 4 minus 2 times 5, it's 2. So this determinant, or this matrix rather, has a determinant, so it will have an inverse. All right, so let's try one that has negatives, because double negatives seem to throw people. So negative 2 times 7 is negative 14, and you're subtracting always. And then negative 5 times 6 is negative 30. So you will have a double negative in this case. So when you have a double negative, remember that it is plus a positive. We add the opposite basically. So negative 14 plus 30 is 16. And yes, you can have negative determinants as well. The answer can come out as a negative, and that's fine. Okay. So, but again, the biggest part that everybody needs to remember is that you are subtracting. So you're subtracting no matter what as far as what the 2 products will be. Okay, so why is this important? Okay, so why is this important? Because we need it to find an inverse. Okay, so we can only have an inverse if our matrix actually has a determinant. So if the determinant of your matrix is 0, then there is no inverse at all. Okay, so and again, you will do 2 by 2s by hand. Anything else, anything bigger than that will be in a calculator. And you also have to make sure it is a square matrix. So meaning that the rows and the columns are the exact same thing. So 2 by 2, 3 by 3, 4 by 4, that kind of thing. All right, so first step in finding an inverse of a matrix is to find the determinant, which was what we just did. And as a reminder, That's AD minus BC, okay, or DA minus BC, doesn't matter. Then you take and you find the reciprocal. Since your determinant is always going to be a whole number, okay, it is literally, the reciprocal is just 1 over whatever you got, okay? So it's just flipping it over. Here's the interesting part, okay? You rewrite your original matrix, your, A, B, C, D. I just want to make sure you understand what this is. You're going to swap A and D, swap positions, and then you change the signs of B and C, okay? And then you're going to take and you're going to scalar multiply your reciprocal times your changed matrix, okay? And that will give you the inverse of the original. So if this is your original matrix, A, B, C, D, then this is the inverse. 1 over the determinant. See how we've swapped these two and changed the sign of these two. Okay? And that's why that determinant, again, is so important, because it gives us our first step. All right, so let's try one. Okay, in steps. So step 1, I'm just going to write it out. Step 1, all right, is the determinant. So -9 minus -2. And since we have a minus a negative, that means we're going to add the opposite. So -9 plus 2 is -7. Okay. Step 2. I need the reciprocal of that inverse. So the reciprocal of -7 is -1 over 7. Okay. Step 3 is that we have to take our original matrix. I'm going to go ahead and erase these lines. And we have to swap and change. Okay. So when I write this, I go ahead and I do the swap first. I go ahead and swap these two numbers. And then I change the signs of both of these. Okay. And as stated, step 4, you take the reciprocal of your determinant and you scalar multiply it times the changed and swapped matrix. And you're going to get a lot of fractions in these. Just go ahead and leave it as a fraction. Just do please simplify your fractions. Okay? But you get a lot of fractions in these. It happens all the time. All right, so if we're going to multiply these and we're going to simplify, we have -1/7 times -3. And there's a really neat thing, being that this is 1 over a number, whatever your determinant is, these all end up, all the numbers inside your matrix end up pretty much being the numerator in your fractions, and they all have this denominator before you simplify them. Okay, so this is really -3 over -7, so we're just going to make that a positive. All right, and this is going to be -1 over 7 since we don't have the double negative here. Here we have the double negative again, so that's going to be 2 over 7. And the last one is going to be -3 over 7. Now, we'll do a couple more just to make sure, and then that'll be it for this lesson, and then you'll literally just do some practice problems for this, and then the next video will be about solving using the inverses. All right, so let's try a couple more just to make sure you're comfortable. All right, so sample 2. All right, so let's go through and find the inverse. And by the way, if you ever see for the notation, remember that we name our matrices by a capital letter. When we do our inverse, we list it like this. Raising something to the -1 power is the same thing as stating the inverse of it. All right, so let's go through. All right, step 1, 30. minus negative 12 equals 42. Okay, so and I think I wasn't supposed to do that quite yet. Let's try that again. So 42. All right. Step 2, reciprocal, would be 1 over 42. Okay, step 3 is our swap and change. So remember, swap and change. Okay, so we're going to swap the 5 and the 6, and we're going to change the signs on the 4 and the 3. Okay, and then the last step is to scalar multiply the reciprocal times the original, or times the swapped and changed original. Please make sure you're reducing as you go so that you can get your lowest fractions, but definitely, it is going to be a fraction and it's okay. So 5 over 42 does not reduce, so that one's fine. 4 over 42 does reduce, that's going to be 2 over 21. Okay, negative 3 over 42, believe it or not, actually does reduce. I believe it is 14. Negative 1 over 14 since it's a negative, I think. And then 6 over 42 reduces down to 1 over 7. That one I know of. And so that is the inverse of our original matrix. Okay? And we'll use inverses to solve. That's the reason we go ahead and do it. Real quick as a backtrack, we use the determinant sometimes instead of solving. We use the determinant to actually find the area of a triangle. It's actually pretty interesting. Let's make sure. No. Yes, okay. So we can use the determinant to actually find the area of a triangle. And again, it's pretty cool. So we were doing matrix to represent shapes basically and transforming. We can actually write a matrix to represent a triangle and then find its area. So it's actually pretty cool. Before, the x values went in the first row and the y values went in the second row, and this was written as like a horizontal matrix. It's a little different this time because now you're looking at columns. So the x's go in the first column, the y's go in the second column, and then we add a column of ones to make it a square matrix. Okay? So it's actually pretty cool. It's just a side note that you can use with the determinant is you can use it to find the area of a triangle as long as you have all 3 coordinates. Okay, so let's try one. Again, just as a side note. Okay, so our triangle points are 1, 6, 2, 4, and negative 1, negative 1. And notice, see, this is the x column, 1, 2, negative 1. This is the y column, and this is the extra column of ones that we throw in there. Okay? Now, this is a 3 by 3, and this goes in your calculator specifically, all right? And in your graphing calculator, this is how we do this. You go to second x to the negative 1, and if you look, what's printed in blue, which is what we get by using the second, over x to the negative 1 is the matrix menu, okay? So you do second x to the negative 1, and then you right arrow over to math, and the first thing listed under the math is your determinant, DET, okay? So this is how we're going to find the determinant of a 3 by 3 matrix. So do second x to the negative 1, right arrow over to math, and select the first option. So it's determinant, you just hit enter. And then we go to alpha, which is the green button, and zoom. And if you go to alpha zoom, it's going to give you the option, like a little shortcut option, of putting in a matrix, okay? And you need to let it know that you have a 3 by 3, and it's asking you in this little vertical way, if you're looking at your graphing calculator, of how many rows and how many columns do you have for your matrix. So you go up and you hit the up arrow and select a 3 by 3, and then come down and hit OK. And what's going to pop up on your screen is going to look like this. It's literally going to say DET parentheses, and then you're going to have this bunch of boxes that you have to go back and fill in because it's a 3 by 3 matrix. Okay, use your right and left arrow keys, and if you keep hitting the right arrow key, it'll go 1, 2, 3, and then it'll go down to the next row, and it'll keep doing it. You're going to enter all these numbers. Okay, you're just going to type in the matrix. So we're looking at 1, 6, 1. Okay, 2, 4, 1. And then the bottom row is -1, -1, 1. And if you give me a minute, I will grab my calculator to make sure that this works and that we can put it in, that we're going to get the same answer. Now, the only thing that you have to remember, since it is a triangle, right, we need half of whatever the determinant is, because like the area of a triangle is half the base times the height. This kind of gives you the base and height of your triangle in the coordinate plane. Okay, so give me a minute. I'm going to go grab my calculator. Okay, so I've got my calculator. That way we can do the problem together and make sure we get the right answer. So let me type mine in. 1, 6, 1, 2, 4, 1, -1, -1, 1. Okay. I'm going to find the determinant. Okay, so determinant of A, and should have gotten -11. Okay, remember we don't do negative area. So if you came up with -11, which unless I messed up, should be what you would come up with. Let's make sure I typed it in right. 1, 6, 1, 2, 4, 1, -1, -1. Yep, okay. Yep, so -11. And since we don't have negative areas, we basically take half of that and make it positive. So -1/2 times -11, so no negative areas, is going to be 5.5. And since it's an area, we're going to go ahead and make sure that we say that this is 5.5 units squared, since it is an area. Okay? So it's just a little side thing as far as what you can do with a determinant. It's actually pretty cool, a way of finding the area of a triangle that's in the coordinate plane. Now, back in, 9th, 10th grade, you would have to go and find the distances or the lengths of all the sides and, try to figure out height and base and all that kind of stuff. Well, it's a shorter way of doing it with a determinant. So, but your work for this is literally just going to be finding the inverses of triangles. And let me grab my book so I can tell you which ones to do. And then this video will be done and you can work on inverses and determinants. Let's see. No, let's see. Yes, I think we're actually in section 8.4 finally. We've finally gotten out of section 8.3. Yes. Okay, so in your book, we are in section 8.4. We are on page number 853 through that actually might be it. Yeah, just 853. Okay, so okay, so problem numbers 13 to 18. Now, pay attention because I don't want you to do the last step in this. Well, no, not yet. What I want you to do is I just want you to find the inverse of all 6. Okay? And then we'll talk in the next video about what happens when you multiply a matrix times its inverse and see what happens. Okay, so that's the video and the assignment for this one. And we're done.